Hey guys, so in the last lecture we have seen power transmitted and maximum power transmitted. So in that we have seen the formula for centrifugal effect on the belt. So today we are going to discuss and derive that formula for centrifugal effect on belt. So suppose this is our pulley and suppose this is the belt tension on the both the sides, that is centrifugal tension, the tension due to centrifugal on both the sides. So this was TC and it is creating, suppose, an angle. Suppose, let me divide the circle. uh, so it is creating an angle of theta delta by 2 and theta delta by 2, and the point of contact, this is creating total angle theta delta. So the centrifugal tension will be same on both the sides. So while it is in motion as belt passes over a pulley, the centrifugal effect due to its own weight tends to lift the belt from the pulley. So the centrifugal force produces equal tensions on both the sides of the belt, that is on the tight side and on the slack side. So let define few parameters. So suppose let m is equal to mass of belt per meter length, that is mass per belt mass of belt per meter length in meter and mass in kg. So unit will be kg per meter. V is equal to linear velocity of the belt. So linear velocity of belt, so you can call it as meter per second as a unit. Then r is equal to radius of pulley. So this is the radius of the pulley. So this is r, you can call it. Then tc is equal to centrifugal tension on tight side and on the slack side, centrifugal tension on both the sides. And fc will be the centrifugal force. Fc will be the centrifugal force. So now Fc, centrifugal force, what is the formula for force? So we know that formula for force is mass into acceleration. So here if I want to sorry I am just writing mass as m dash. So if I want to find the mass here, so mass will be here, the mass of the belt will be m into the length. So it is m into L into acceleration A. Now what is m L? So m I am just writing as it is, and L. So now what is L? What is the length? So here the length will be, so what is the length? So length will be r into delta theta. So this is the length. So it will be as we know that what is the length of the arc. So the length of the arc will be nothing but it will be angle upon radius. So it is angle, so arc length will be angle upon radius, so it will be r into theta. So it will be r into delta theta into a acceleration. Now what is the centrifugal acceleration? So that is v square by r, as we know that it is v square by r. So r gets cancelled, so we are here left with fc is equal to what we are left with here, that is m delta theta into v square. Now from this figure, if we resolve the forces radially, so what we will get is that that is 2 times, that is 2, if we resolve the forces radially, it is 2 times tension into sine. So if I on this direction, so it will be sine delta theta by 2. So 2 times, so this will be in downward direction tc, and this also will be in downward direction tc. So total force will be 2 times. So centrifugal force is 2 times tc sine delta theta by 2. So as theta is very, very small, so we can write sine theta is equal to theta. So and 2 gets cancelled. So FC will be TC delta theta. So now if we compare both these equation of centrifugal tensions, centrifugal force, so we will get that m delta theta v square is equal to tc delta theta. So delta theta gets cancelled, so we are left with centrifugal tension tc is equal to m v square. So this is the formula that we have used. Generally uh, the formula for centrifugal acceleration is v square by r, and for force is mv square by r. We generally use mv square by r. So for centrifugal tension is mv square. So now to depend on only the velocity of the belt and the mass of the belt. Also the centrifugal stress in the belt, if I were to calculate, so suppose sigma c will be equal to centrifugal tension Tc upon cross section area of the belt AC. So it will be Tc upon A. So Tc will be equal to sigma into A. So this is the maximum tension in the belt. So total tension on the tight side. So total tension on the tight side tension will be equal to friction tension, that is T1 plus Tc. On the slack side will be T2 plus Tc. So these are the tensions which will be developed in the belt. Now let's see the next topic, that is creep of a belt. It is creep of belt. So when a belt passes through slack side to tight side, so when from slack side to tight side, a certain portion of belt extends and it contracts again and again. So when on the tight side it will expand, and on the slack side it will contract. So when the belt passes from tight to slack side, so due to this changes of the length, there is a relative motion between belt and pulley surface, and this relative motion is called creep. So this relative motion is called creep. So the total effect of creep is to reduce the speed of the driven pulley or a follower. So what is the goal of this creep? To reduce the velocity. So to reduce the speed of the driven pulley or a follower. So considering creep, velocity ratio, suppose velocity ratio, that is n2 by n1 is equal to, suppose, d1 by d2. So this is our formula, but there will be a multiplication of a factor to uh, consider creep. So that is e plus under root sigma 2 and e plus under root sigma 1. So what is this sigma 1, sigma 2 and e? So sigma 1 is the stress on the tight side, and sigma 2 is the stress on the slack side, and e is the Young's modulus of the belt material. So this is a formula, no derivation, just a formula. If it's asked in exam for 2 marks, so you have to remember this, or it is asked in a numerical to find the velocity ratio including the creep. So now next topic is chain drive. So this is the last topic of this chapter, so that is chain drive. So what is a chain? So a chain is regarded in between the gear drive and the belt drive. So it is between the gear drive and the belt drive. So here it comes chain. So like gears, chains are made up of metal. So it is made up of metal, and so it is require less space and gives constant velocity ratio. As belt, it is used for longer central distances, for long distances. So it is having the quality of both belt and gear, so it is widely used application. So what are the advantages? So constant velocity due to no slip, so it is a positive drive. So it is a positive drive. No effect on overload on the velocity ratio. Oil or grease on the surface does not affect the velocity ratio. Chains occupy less space as they made up of metal. Lesser loads Lesser loads are put on the shaft. Higher transmission efficiency due to no slip, though only one chain motion can be transmitted to several shafts. There are few disadvantages. It is heavier as compared to the belt. So as gears are heavier, metal components are heavier, so chains are also heavier. So there are gradual stretching and increase in the length of chain from time to time. Some of the links have to be removed. Lubrication of these parts is required and chains are costlier compared to the belt. These are various advantages, disadvantages, and where it stands from between the gear and belt. So now the next topic which we are going to discuss is the length of the chain drive. So what is the length of chain? So length of chain. So the length of a chain will be calculated as same as open belt drive. So suppose R and R are the radius of the pitch circle of two sprockets and having T and T teeth. T and T teeth. So these are radius and these are teeth. Now if C is the center distance between sprocket and uh, so there is a center distance between two sprockets, so that is K into P. What is P? So P is the pitch of the chain. So if I want to draw for you to explain how you must have seen the chain, but chain is somewhat like this in shape. So these are few circles, and from here the another pair moves ahead, and so this is, and from here another pair moves ahead. So this is somewhat kind of a chain structure which goes which you can connect or disconnect it as per your need. So this is a chain and chain drive structure. Now so there are total two bundles. So as you can see, uh, this element is also below after this element. So there are total three elements. So this first, this second, and there will be a third element similar to this sandwiched between this element. So the connecting element will be sandwiched between the first and last element. So is a figure of a chain drive. You must have also seen in your cycle. So if you bicycle, you have seen that you use chain for drive, and the same is used also in bikes. So now what is the length? If I want to find the length, so we will use the formula for the length for a open belt drive. Similar, what is the formula for length for open belt drive? So it was L is equal to pi into R plus R plus 2c plus r minus r whole square divided by c. So we'll use directly this formula. But here the capital R, so radius, will be p by 2 cosec 180 by t. So similarly the small r will be p by 2 cosec 180 by t. This is a relation between radius and the teeth. So if you want to find in terms of teeth rather than radius, so we are deriving the formula for the length of the belt in terms of teeth. So the it will be L is equal to so instead of R we are writing here what we are writing, that is P by 2. So P by 2, so that is P by 2 will be common. So here then cosec 180 by t. So just wait a second. So here actually I have just mentioned these angles in terms of degrees, and this I have mentioned radius. So let me just replace this in terms of radian. So this will be r is equal to p by 2. So now what is cosec? So cosec also you can write it as there is sine also. So also you can use this term, that is sine pi by t. You can also use this term, and uh, so it will be pi by t. Okay, so and here r will be equal to p by 2 upon sine pi by small t. So for this term we will use this formula. So what it will be, so it will be L into pi into p by 2. P by 2 is common, so p by 2. Now when theta is very, very small, we can write sin theta is equal to theta. So I will just use the theta, so it will be pi by t. So t will go up, so it will be t divided by pi plus t divided by pi. So pi pi gets cancelled here, so we are left with p by 2 t plus t plus here 2c. Now what is c? So c is nothing but kp. So as I have mentioned here, c is nothing but kp. So but what is C? So C is the center between the two sprockets. So this is one sprocket and this is the second sprocket. So the distance between this two, or you can calculate from middle, from anywhere you can calculate the distance between the sprocket, as that is uh, K into P. So P is nothing but pitch. So pitch of the chain. So here I can write, instead of 2C I can write kp and plus here r minus r by 2 whole square. So here I will use this formula in terms of cosec only. So this formula I will use. So it will be nothing but uh, p by 2. So it will be p by 2 cosec 180 by t minus p by 2 cosec 180 by t small t whole square divided by c. C is nothing but kp. Now also the pitch, circular pitch p, can be written as pi dt. So this pitch p can be written as pi dt. So you can also write it as 2 pi r divided by t. So pi r can be written as, p t divided by 2. So if I want to write pi r, plus r, I can write it as pt plus pt divided by 2. So this pt plus t by 2, I can write it as pi r. So as I have written here, instead of pi r plus r, and so this is what I am trying to convey. So this I have mentioned. Now let's see. So now I will just rub that. So what is our length formula finally? So P is common in every term. So P I will take as a common. So we are left with here T plus T divided by 2. T plus T divided by 2 plus K. Here I am left with only K. Uh, so so here it was actually, it was 2C. So here it will be 2kp. So here I am left with 2k plus, now this term, so p is taken out as a common. So now 2 I am taking here in bottom. So as there is a square here, so when I bring 2 outside, so it will be 4. So the term will be here, that is, here we are left with cosec 180 by t minus cosec 180 by t whole square divided by 4k. So it will be divided by 4k. So uh, So you must be wondering that where this p went. Now as you can see, if you take p from this bracket outside, so it will be p square. So here p square and here p, so p gets cancelled, so here you will left with p. So that which you have taken as a common outside here, so you are left with here only k only. So this is the final length of the chain drive. Now next topic is classification of chains. So how chains are classified. So classification of chains. So chains are classified based on various terms. So we will see few chains. That is, first is hoisting chain. Hoisting chain. So hoisting chain includes an oval link and stud link chains. So it will include an oval, so like elliptical type. So it will, this will be an oval link, and so there will be two oval link here, and there will be a stud link in between. So there will be a stud link in between this. So an oval link is a common form of hoisting chain. It consists of an oval link and also known as coil chain. Such chains are used for lower speed only. So it is used for lower speed only. Then there is a conveyor chain. This conveyor chain. So how conveyor chain takes place? So conveyor chain may be detachable or hook type or closed type joint. So it will be detachable or a hook type. So it will be generally in this format. So it will be in this format. So this will be the format. So as you can see here that this can be detached. So this can be easily detached. So such chain, so the sprocket teeth are so shaped that the chain should run onto and off sprockets smoothly without interference. So such chains are used for low speed agricultural machinery. The material of the link is usually malleable cast iron, and the most of the chain is not very smooth. So next type of chain is which is widely used or we use is power transmission chain. So there is power transmission chain, so which I drawed here. So it will be in such a manner that this will be the structure here, and this will be the structure here, and at the back also this will be the structure here, and similar structure will be here. So there's this size problem here, but as you understood that this chain will be connected. So this will be, so are drawn in 3D. So this is a block chain. So these chains are made of steel in which varying parts are hardened, and these are accurately machined and run on carefully designed sprockets. So blockchain, this type of mainly used for transmission of power at low speed. Sometimes they are also used for conveyor chains in place of malleable conveyor chains. Then there are also different types of power transmission. So this you can call it as a blockchain. Similar methodology you can use for roller chain, and also for uh, inverted tooth chain. It is inverted tooth chain. So you can also call it as a silent chain, and this will be inverted tooth chain will be diagram will be in such manner. This will be the diagram. So this will be the hole here. Similarly, there will be another member similar in diagram. So this is inverted tooth chain. So that is the tooth is just inverted, and this will be your pulley which will have a tooth, so similar to the gear type. So this is the inverted tooth chain. Also roller chain. So in roller chain, a bushing is fixed to an inner link, whereas the outer link has a pin fixed into it, and there is only a sliding motion between pin and bushing. And the roller is made of hardened material and is free to turn on the bushing. And this inverted tooth chain is also called silent chain. So, though roller chain can run quietly at fairly high speed, the silent chains are used where maximum quietness is desired. Silent chains do not have rollers, and the links are so shaped as to engage directly with the sprocket teeth, and the included angle is either 60-degree or 70-degree. So this concludes this our chapter, that is belts and chain drive. So we have seen ways of belt equations and also chain drive. So this will conclude this chapter. So thank you very much.